Welcome back. In this session, we'll focus on experimental techniques, the backbone of chemistry labs. You'll learn how to separate and purify substances, measure accurately, and carry out electrolysis safely. These practical skills are not only tested directly, but also essential for interpreting experiment based questions in your exams. Purity tests are simple but vital. Pure water boils exactly at 100 degrees Celsius at standard pressure, while salt water boils higher due to impurities. This principle helps test chemical purity. In labs, use a melting point apparatus or boiling tube and thermometer for accurate readings. Filtration removes solids like sand from mixtures, while crystallization isolates dissolved solids such as copper sulfate. To crystallize, heat until a concentrated solution forms, cool slowly, and filter out the crystals. Evaporate gently to avoid decomposing the solute or losing solvent too quickly. Distillation relies on boiling point differences. Simple distillation is for wide differences such as water from salt solution. Meanwhile, fractional distillation uses a glass column packed with beads to separate liquids with close boiling points, for example, separating ethanol from water. In paper chromatography, draw a pencil line, place ink spots on it, and dip the paper in the solvent below the baseline. As the solvent rises, components move at different speeds. Calculate RF values to identify substances and always use pencil. Pen ink would interfere with results. Gas syringes give accurate gas volumes, while water displacement works for gases insoluble in water. Use a burette for titrations and a pipette for fixed liquid volumes. Always read the meniscus at eye level and note whether it curves upward or downward for accuracy. To collect hydrogen, use upward delivery since it's lighter than air. Carbon dioxide, being denser, is collected by downward delivery. Overwater collection works for gases that don't dissolve easily. To dry gases, bubble them through concentrated sulfuric acid or calcium chloride pellets. Electrolysis splits compounds using electricity. Cations gain electrons at the cathode, where reaction occurs, and anions lose electrons at the anode, where oxidation occurs. The process requires free moving ions, so electrolysis is done on molten salts or aqueous solutions where ions are mobile. In molten lead bromide, the lead ion goes to the cathode forming lead metal, while the bromine ion goes to the anode forming bromine gas. The electrodes show clear evidence. Metal deposits on the cathode and brown vapor forms at the anode. Always state both half equations in exams. For aqueous sodium chloride, hydrogen forms at the cathode and chlorine at the anode. The solution becomes alkaline due to the formation of sodium hydroxide. Remember, the less reactive species is usually discharged. Exam questions often ask which ions are present and what products form at each electrode. In any lab experiment, accuracy and safety go hand in hand. Repeat experiments to improve reliability, control all variables except one, and use appropriate apparatus. Always wear goggles, handle acids and alkalis with care, keep flammable materials away from flames, and report spills immediately. To recap, we examined how to separate and purify substances, test for purity, collect gases, and perform electrolysis safely. Mastering these techniques ensures success in both practical and theory exams. They connect fundamental chemistry concepts with real world lab applications. Thank you.